Hello guys, so welcome to your channel which is Science Engineers. This is Sushant. So we have already started uploading videos for your Applied Mathematics 2 and we had started with your first order differential equation. So if you are new to the channel, do subscribe to our channel, do share our videos and do like them. The liking and sharing of the videos will help us make more videos for you in the coming future. We are associated with the Samartha Vidya classes, which is group tuitions for the engineering and science students. We conduct classes for all the subjects of your first year of engineering. So for this particular sem, we conduct classes for your mathematics, engineering drawing and SPA. So if you want to inquire about those batches, then you can do so by emailing us at samarthavidya@gmail.com, or you can visit our Facebook page. We conduct classes for the regular batches, the vacation batches and also for the KT batches. So for the schedule of those batches, you can just email us at samarthavidya@gmail.com. So today we are going to continue with our topic, which is exact differential equation, which comes under your first order, first degree differential equations. We have already uploaded a video for that, wherein we had explained what basically exact equations, differential equations are. So let's get going with today's topic. Now in the earlier video we had discussed on our exact differential equation and how to identify them, and once we have identified them, how to solve them. In this particular video, we are going to see those differential equations which are not exact differential equations, but can be reduced down to an exact differential equation. So in such cases, it's basically not going to be satisfying the condition of your exact differential equation. And once that is proved, then there are various rules by which it can be reduced down to an exact differential equation. So let us see what are the various rules which are applicable for reducing a differential equation into an exact differential equation. There are basically 4 different rules which are present for this particular topic. So let us see the 4 rules by which we can reduce our differential equation into a exact differential equation, that is a non-exact differential equation into an exact differential equation. So first of all, you have to prove whether it is an exact or a non-exact. If it is a non-exact, then these 4 rules can help you to bring it down to an exact differential equation. So what you mean by that is basically you have to find an integrating factor by multiplying it with the differential equation. That particular equation becomes an exact differential equation. So our main intention is to find the integrating factor, which basically has to be multiplied with the given differential equation to make it into an exact differential equation. So let's go for the first rule. You can see that in the first rule we are calculating dou m by dou y minus dou n by dou x divided by n. If this particular equation is leading to a function which is going to be in x only, that means there is no y term present in it, then if I say that that particular function is f of x, then my integrating factor is given by e raised to integral f of x dx. Coming to the second rule, which is just like this, only the terms are reversed in this. So we have dou n by dou x minus dou m by dou y divided by m, which is to be a function of y. So in the second rule, we are finding whether the particular equation which we are using is going to be function of y or not. In the previous one, we were finding whether it was function of x. So in the second rule, if it is a function of y, if I say that function is f of y, then the integrating factor is given by e raised to integral f of y dy. Coming to the third rule, in the third rule, if I am having my differential equation in this form, that is, it's going to be function of some xy into y plus some function of xy, some other function of xy into x, this thing will be equal to 0. Then in that case, we will be finding simply this particular term, which is mx minus ny, which should not be equal to 0. So here m is nothing but this particular term which we were having, that is m dx term, and your n is nothing but the n dy term. So if I am having this particular relation that it is not equal to 0, then only I can use this particular thing, that is integrating factor is equal to 1 upon mx minus ny. So now if you are not getting what this means, basically this is function of xy, that means the terms which will be involved in it can be in this form, that is cos of xy or tan of xy or something like xy the whole square or root of xy, something like that. So it's always going to be the x and y should be in pairs together whenever a function is present for it. Coming to the last rule, in this, if my m dx plus n dy, which is a standard form of your differential equation, if it is homogeneous, that means that each and every term has the total degree of a common degree, a same degree, each and every term has the same degree, then in that case we have to find this particular term, that is mx plus ny should not be equal to 0. If it is so, then I can have my integrating factor which is going to be equal to 1 upon mx plus ny. So these are the 4 rules which are basically useful to find the integrating factor. Once you find the integrating factor, you have to just multiply the integrating factor with the given equation, and then that becomes an exact differential equation, and then you will be applying the basic solution which is useful for your exact differential equation. So let us see some sums which will be based on these rules and how to identify them. So in this particular, there is no hard and fast rule how to identify them. You have to basically go for a trial and error method. In the last 2 methods, we can actually identify which type it can be, because the type is being mentioned over here, because this should be in as a function of xy into y, a function of xy into x. And in the last term, it should be a homogeneous. But in the first 2 rules, it is no hard and fast rule to identify them. It's basically a trial and error method which we go for it. So let's see some sums which will be based on the first 2 rules. Let's have a look at this particular sum which is given. We have 2x log x minus xy dy plus 2y dx is equal to 0. Now in this, you have to first of all identify which is going to be m and which is going to be n. So always the m term is with dx, so therefore we will be having m as 2y, and my n is with dy, so that is going to be 2x log x minus xy. Once you have done with this, then you go for the checking of whether it's going to be an exact or not. So for that you require dou m by dou y. So it's simply partial derivation of this with respect to y. So we just have one term, so that is why it's going to be 2. Then going for this, that is dou n by dou x. So it's a differentiation with respect to x of this particular equation. So you can see that we have a 2x log x, which is nothing but your uv rule. So that is going to be 2 into derivative of x, which is 1 into log x as it is, plus 2 into x into derivative of log x, which is 1 upon x. Then in the next one we have xy, wherein your y is constant, so it's going to be minus y, and derivative of x, which is going to be 1. So obviously you can see that your dou m by dou y and dou n by dou x is not equal to each other. So that means that this particular differential equation is not exact. So once we have proved that it is not exact, then you go for the checking of the rules which we have just discussed. So checking the equation, you can see that it is not fitting the last 2 rules. It is neither in the terms of function of xy into x and function of xy into y. Neither of it is present, or nor it is a homogeneous equation, because the degree of individual terms is not same. So that is why we cannot apply the last 2 rules. We have to go for the first 2 rules. So in that, basically it's a trial and error method. So let us go for the first one, that is dou m by dou y minus dou n by dou x divided by n should be a function of x. If I just substitute these values, I will be getting this as 2 minus 2 log x. The x over here gets cancelled, plus basically it's a minus of that, so minus 2, and this becomes plus y, and divided by n. So my n over here is 2x log x minus xy. So from here you can see that 2 gets cancelled out. So we have basically a minus 2 log x plus y which is present in the numerator. In the denominator, if I take x common or minus x common, I'll be getting this as minus 2 log x and plus y. So you can see that this term gets cancelled and you're remaining with a term which is minus 1 by x. So this particular term is only function of x, that is why we can say that this is equal to f of x. So we have found that our function f of x is nothing but minus 1 by x. So after this we need to just find the integrating factor. So integrating factor is going to be equal to e raised to integral f of x dx. So which is equal to e raised to minus integration of 1 upon x dx. So 1 upon x dx integration is e raised to minus log x. So this log is going to be your natural log, or you can write it as ln. So now we have to get rid of this e. So what we do is we will take the minus 1 inside, so that becomes e raised to log of x raised to minus 1. So e and log basically nullifies each other. So we'll be having this integrating factor as 1 upon x. So you can see that this is nothing but our integrating factor. So this integrating factor has to be simply multiplied with the given equation to reduce it down to an exact differential equation. So once you multiply the given equation, what you get is you will be getting this as 2y upon x dx plus it's going to be 2 log x minus y dy is equal to 0. So this becomes your m and this becomes your new n. So the solution of this equation, now this has become an exact differential equation. So that will become as, the solution is integration m dx plus integration n dy is equal to some constant c. So in this we should have y constant, and in the second integration it is no terms of x. If you do not know this rule, then you can just refer to our earlier videos wherein we have discussed on this. So it's going to be integration of m, which is this part, and you can see that your 2 and y is constant over there, so that comes outside. So it's integration of 1 by x dx plus in this you require no terms of x. So you can see that the first term is present, which is of x, and the next term, that is y, is without the x. So I will have that as minus y dy. So on integration you will be getting this as 2y log x minus y square by 2. This thing will be equal to some c. So this is going to be your solution of the given differential equation. So let us see one more problem which will be based on. So now let us observe this particular question which is given to us. We have x e raised to x dx minus dy plus e raised to x dx plus y e raised to y dy. Now you can see that we do not have a precise equation, that is, it is not in the form of m dx plus n dy. So we need to find it in that. So basically we'll be opening up this bracket, taking the dx terms together and the dy terms together. So on opening the bracket and rearranging them, the dx terms will be x e raised to x plus e raised to x into dx, and the dy terms are going to be minus x e raised to x plus y e raised to y dy. So now you have this as m, and this term is nothing but your n. So we have to find your dou m by dou y, which is nothing but differentiation with respect to y for your m. So in m you can see that there is no term of y at all. So that is why the x will be treated as constant and you will be getting this as 0. Next you will be checking for dou n by dou x. In this you will be differentiating it with respect to x. So you can see that you are having only this term which is present of x, and this will become 0 because it is in y, so that is considered as constant. So you will be having a UV rule over here, so that's going to be minus e raised to x minus x e raised to x. So now you can see from the differential equation it is not fitting the last two rules. So it can be either the first rule or the second rule. So let us go and check for the first rule. So that is going to be dou m by dou y minus dou n by dou x. This thing should be divided by n. So if we are checking that, we'll be getting this as 0 minus of this, so that becomes plus e raised to x plus x e raised to x divided by n. So that is going to be minus x e raised to x plus y e raised to y. So you can see that this cannot be further solved. So it has to be like this only. So this is not in terms of x only because we have the y terms also in this. So that is why the first rule is not applicable. So we have to check for the second rule. So going for the second rule states that it is dou n by dou x, which should be the first term, minus dou m by dou y, which should be the second term. This thing should be divided by m. So if I am substituting, I will be getting this as minus e raised to x minus x e raised to x minus 0 divided by, I will be getting this term as x e raised to x plus e raised to x. So if from the numerator, if I take the minus 1 common, I will be getting this term as minus e raised to x plus x e raised to x divided by x e raised to x plus e raised to x. So this basically gets cancelled and I get this as minus 1. So this basically is a constant term. It can be considered as a function of y. So I will be considering this as your f of y. So now once you get this f of y, then the integrating factor is going to be simply e raised to integral f of y dy. So you are integrating with respect to y. So on integration you will be getting this as minus dy. So it is e raised to minus y. So your integrating factor is nothing but e raised to minus y. Once you get the integrating factor, you have to just multiply. So on multiplication with integrating factor, you will be getting your new differential equation in this form, which is going to be your exact differential equation. So directly then going for the solution. So the solution is going to be, it's going to be integration of this part wherein we will be keeping the y term constant. So directly writing it. So it's going to be e raised to minus y, which is going to be outside. Integration of x, I'm taking the e raised to x common, so x plus 1 e raised to x dx, plus it's going to be integration of n wherein we should not have any terms of x. So you can see that this particular term should not be written, so we'll be having only this particular term. Now this thing will be equal to constant c. Now from the first integration you can see that it is e raised to x into x plus 1. So if I consider this as function of x, the derivative of that is present over here. So this is of the type e raised to x into f of x plus f dash of x, whose integration is going to be e raised to x into f of x. So that is why after solving this you will be getting this directly as x into e raised to x as the integration of this, plus it's going to be y square. So y square by 2 is equal to some constant. So this is how you will be basically solving the first two rules, or identifying the first two rules and solving them accordingly. We'll be seeing the next two rules in the next video. So till then, just keep watching our videos, keep liking our videos and sharing our videos. Do subscribe to our channel to get regular updates of any uploads which we are doing on the regular basis. If you want to inquire about us for our classes for ED, SPA or M2, you can do so by contacting us at samarthavidya@gmail.com, or you can visit our Facebook page, which is for Samartha Vidya. The link for the page and the email address is given in the description below. So for now, keep learning, keep watching, and happy learning. Bye.